Okay, we are ready for lesson 9 of module 2. The title of this is Sequencing Rotations. So we spent several lessons just talking about what a transformation was. We learned about 3 types of rigid transformations: translations, rotations, and reflections. And then we start talking about what if we performed one transformation after another, what types of things would happen there. So we've been looking at sequences of translations and reflections, and so now we're going to do rotations and see what happens with those. And this lesson is called an exploratory challenge, and so it's designed for you to just work and see if you can discover some things about sequencing rotations. So it's gonna look a little different than another lesson. So let's see what this looks like. Okay, so what I'd like you to do is work through these exercises, and there are several of them, and see what you can do on your own. And what I'm going to do is this video is just going to show you the results for all the different challenges. So if you'd like to do it one by one and check your results, that's fine. Or if you'd like to work through all the challenges and come back and watch the video, that'd be okay too. You can use it however it works for you. If we were in a classroom, I'd probably have you working in pairs. So it's perfectly fine to be working with another student or a parent or somebody. In fact, that would be a really good thing to do. Okay, so go ahead and pause the video now, and then when you come back, I'll show you my results for these challenges. All right, so in this first challenge, we're given triangle ABC, and we're told to rotate it around center D and label the rotated image. And we get to choose the degrees. It's just any number of degrees that you want around that center. And then we'll take the rotated image, so the one that we already rotated, and rotate it again around a different center, center E over here. And then label that rotated image. So let me show you what I did, and yours will look different because you used a different degree of rotation around these centers. But what I did was I started down here with this triangle and rotated it around center D roughly 90 degrees, and it ended up to be this triangle right here. So this is A prime, B prime, C prime, and then I took this angle and rotated it around center E way over here using my overhead, and I rotated it just a little bit over that way. And I ended up with this new A double prime, B double prime, C double prime. And so there's our 2 rotated images. And we're asked in part C to measure and label the angles and side lengths of these triangles. And I measured BC at 4 centimeters and the images at 4 centimeters. And I think it's pretty intuitive that all these measurements will be the same because the sequence of rotation is just copying that exact triangle as we go along. So all of these measurements, all these angle measures will be identical. And let's, just in case you didn't measure them, angle B, this one is 112. I can't fit it inside with this fat pen. 112 degrees. Angle C is around 21 degrees. and angle A is around 47 degrees. This would be about 5 centimeters. So down here, this is 5 centimeters, and so on. So all the measurements are the same in those. So what we can get out of this is that even when sequencing, if, you know, when we're asked in Part D to explain how we know, explain what we observed, we know that a single rotation from here to here would preserve all the measurements, the lengths of segments, degrees of angles, and so on. And so if performing one rotation does that, just rotating it one more time is going to have the same effect. So the final effect is that a sequence of rotations preserves all the measurements of the original figure. Okay, so let's move on to exercise 2. All right, here's exercise 2. In this exercise, we're told to rotate triangle ABC around center D, and then D degrees, and then rotate again D degrees around center E. Now, even though it uses the same variable twice, D, it's any number of degrees that you want. And then we are to label the final image as A prime, B prime, C prime after you complete both rotations. Okay, so here is what my triangle was, and depending on the number of degrees you rotated around both of these centers, E and D, your triangle will end up in a different place, and that's perfectly fine. But what you should have noticed using your overhead was that if you tried to get back to this original triangle by doing a single rotation around E or D, it wasn't possible. You could rotate your overhead 360 degrees around, and it would never fall back onto triangle ABC. And that's because you use 2 rotations to get it over to this location. So this was kind of a tricky thing, and it was trial and error. Part D says, can you find a center that would map A prime, B prime, C prime onto ABC in one rotation? And it turns out that you can actually do that, and you'll see I did it right here. I found a center F that if I held F down, I could get ABC to come right back around and coincide exactly, or A prime, B prime, C prime to coincide with ABC. And the way I did that was just by hunting around and experimenting by holding my overhead down in this spot, F, many times. It took a little bit of hunting and pecking, and if you didn't find one for yours, that's okay, but I challenge you to go back and find it. And it should be somewhere around D and E, but it's not going to fall exactly on either of them. It's going to be somewhere around there, and it will depend on the rotations that you did, where your center is going to be that will map it back on. I wish I could demonstrate that for you, but we're not there. So we'll look at that again on next Monday if people have questions about it. So there is a point after I've done these 2 rotations, and when you're in high school geometry, you can actually predict where that point will be. You can figure it out mathematically, but for now we're just going to do it by trial and error. Okay, so that is exercise 2, or challenge 2, and we saw that we couldn't get back to the original rotation by using either of those centers, but we could find another center. Okay, let's look at the next challenge, challenge 3. All right, in challenge 3, which looks very similar to 2 but has different directions, we have again 2 centers of rotation, D and E. We have triangle ABC, and we're asked to rotate triangle, I'm reading right here, rotate triangle ABC 90 degrees counterclockwise around center D, and then rotate the image another 90 degrees around center E, and label the image A prime, B prime, C prime. Okay, and then we're to come back and do the same thing, except this time we're going to go around E first and then D, and label the image A double prime, B double prime, C double prime. And then we're asked what we notice about the 2 images, and we're going to see if the order that we rotate the figure matters. Okay, and you should have found that the order does matter, and I'm going to show you a picture of what my rotation looked like when I got done. Okay, so here's what my results look like, and you'll notice that I did something here with my centers of rotation D and E. Is I drew these little dotted right angles here to help me do my 90-degree rotation. You guys did a good job with that on Monday, so you probably didn't have any trouble. But I used my overhead and took triangle ABC, rotated it 90 degrees around center D, and ended up somewhere up here. And then I went another 90 degrees counterclockwise around center E, right here, and ended up, can't draw an arrow, and ended up right here. So this was after 2 rotations, first D, then E. I came right there. Then I came back to my original triangle, rotated it around E first, and then around D again, and it actually ran off the paper. So I got up here in the corner, so this was A double prime right here, but B double prime and C double prime were off the paper. But the point being that when I did the same exact rotations but in a different order, my image ended up in a different location. Still a congruent image, still the same size, shape, all the same measurements, but in a completely different place on the plane. And that's what you should have discovered with this challenge here, challenge number 3. Okay. All right, here is my result for exercise 4. Exercise 4 was a little different because we only have one center. We're still sequencing rotations, but we only have one center of rotation, and that center is D. So I did a 90-degree and then a 45-degree rotation around center D, and got this triangle A prime, B prime, C prime right here in the, right there. To do the 90-degree rotation, once again, I did these dotted lines here. To do the 45-degree, I cut my 90 in half, and that allowed me to rotate just that amount, the 45 degrees. So that was helpful to do that. Now, when we did the rotation, just like before, we sequenced these differently. First the 45 and then the 90. And what you should have discovered is that it doesn't matter. The image of triangle ABC ends up in the exact same place no matter what order we do those rotations in. And the difference being that we have only one center of rotation. So as long as we have the same center of rotation, the order does not matter. And I don't have question C on here, but that's where you would have written that. The order doesn't matter as long as we use the same center of rotation for our sequence of rotations. Okay, let's move on to the very last challenge here. This challenge, you may not have been successful in figuring out what it was, or you may have, and you may have something different from what I'm going to show you. But I'm going to show you a way that, sort of a technique that you'll be using a lot in proving certain figures congruent. So what I'm going to do, let's talk about what we're being asked here. Triangle ABC has been rotated around two different centers, and the image is A prime, B prime, C prime. We are asked, so we know that we can't just rotate it back in a single rotation on either of those centers. We have to find a new center, but there's another way we can get A, B, C to map onto its image. And so we're asked to describe a sequence of rigid motions that would map triangle ABC onto A prime, B prime, C prime. And one of the ways you could do that is to first slide and then rotate. So I'm going to do a slide, and there's different ways. This isn't the only way to do it, but I can slide. If I draw a vector from C, this is from C to C prime, and I slide this triangle up here, so it would look something like, this is very rough. If I slide, so this would be A, no, that's not good at all. Here, let's fix that. So what would this do? I don't have my overhead, so I'm having to do this freehand. So I would slide point A up. Okay, this would be parallel like that. A would be up here somewhere, something like this. I've slid ABC up along this vector, so I would have the same vector here and here too. So there is my slide, and then what you might notice is that I'm going to get rid of this mess. Is that I can now rotate this image here around C prime until it coincides. So I'm going to rotate all the way to here, and that will map this figure right onto its image. Okay, so the sequence of rigid motions would be translate on vector C prime. That would be my first rigid motion. Then I would rotate on center C prime until triangle ABC, just call it triangle ABC, coincides with or maps onto, how I want to say that, till triangle ABC maps onto triangle A prime, B prime, C prime. So it's a translation and then a rotation. but it's a specific translation, CC prime, and then a rotation around center of rotation C prime until it maps on there. Okay, you'll have one like that on the homework, and you can do it. So let's real quick summarize what we've learned here. Okay, so let's just go over this together, and this is pretty much what's on your lesson summary on your problem set. But we saw that when we sequenced two rotations, that it had all the same properties as a single rotation. In other words, the important thing is it preserved lengths and angles. All the angles were the same. It's a rigid motion. No measurements changed, no shapes changed. The order, and okay, secondly, the order that we do a sequence of rotations around two different centers matters. The image will end up in a different place depending on the order that we do it in. But if we're going around the same center, the order that we do it does not matter. We can do two rotations or three or more. The image will end up in the same location on the plane, regardless of what order we do the rotations in, as long as it's around the same center. When a figure is rotated around two different centers, we can find a sequence of rigid motions that would map the original figure back onto that image. So that was where we drew the translation vector and then rotated the image to map it up. Okay, so it's kind of a trick, but it's more of a technique that that works really well and makes it easy to describe how to map those two images onto one another. Okay, so you're ready for your exit ticket and your problem set. So good luck. Hope it goes well. Call if you have questions.